Good day, my name is Jeevan Chettiar and I'll be representing Group 1 from Section 2 and I'll be introducing the title of our group report, which is Improving Service Operation Efficiency and Ergonomic Design at Pak Yuzu Jagung Manis BP through Industrial Engineering Methods. Before that, let me introduce my group members. First we have myself, Jeevan, followed by Adib, Hakimi, Ahmad, Fariz, Irfan, Husaini and finally Haniff.
Assalamualaikum and good day everyone. My name is Fariz Faizal and let's start with introduction. In this project, we focus on improving service operation efficiency and ergonomic design in the small-scale food service business. The food service industry plays an important role in providing fast, affordable and convenient food to the customers. In Malaysia, many food stalls are small in size and are usually operated by only one person. Because of this, most of the work is done manually, especially during busy hours. However, many small food stalls operate without a proper analysis of their service process or workstation layout. So, this often leads to inefficiencies in service and physical strain on the operator. Therefore, this project used Pak Usu Jagung Manis BP as a case study. This stall mainly sells corn in cup, which is the most popular menu, especially during peak demand. The service process involves order taking, cooking, mixing, packing and payment, all done by a single person. Because of this, both service efficiency and ergonomic conditions are very important to ensure smooth operation. Let's continue with the problem statement part. Even though the corn in cup is a popular menu, there are several problems in the current service operation. During peak hours, customers often wait for a long time. This happens because the cooking and mixing process is done manually and takes longer time, creating a bottleneck. At the same time, the operator faced ergonomic problems such as standing for long periods, bending the body, reaching for the tools, and being exposed to heat while cooking. This issue can cause fatigue and discomfort, which may affect service performance. The objectives of this project are clearly defined. The first objective is to analyze the current service process of the corn in cup operation at Pak Usu Jagung BP using a time study method. The second objective is to identify bottlenecks and inefficiencies in the service cycle that affect service speed and productivity. The third objective is to assess the ergonomic risk faced by the operator during service operation. Finally, the project aims to propose feasible improvement solution using industrial engineering tools to improve service efficiency and reduce physical strain on the operator. The scope of this project is focused specifically on the corn in cup service operation at Pak Usu Jagung Manis BP. This project includes process flow analysis, time study, and ergonomic evaluation of the operator during normal working conditions. Industrial engineering tools such as REBA and the 5S methodology are applied to analyze and improve the workstation and service process. However, the study does not include financial analysis, customer satisfaction surveys, or changes to the menu. The proposed solutions are designed to be practical, low cost, and suitable for small-scale food stalls without increasing manpower or making major changes to the existing.
Assalamualaikum and good day. My name is Haniff. My metric number is CD230253. Now I will begin my part of the presentation. So the literature review establishes why we must look at efficiency and ergonomics as one single system. In industrial engineering, we define efficiency by how quickly a customer is served. However, our research shows that efficiency is often destroyed by bottlenecks. Those slow manual steps like the steering process at Pak Usu's stall. So what the literature makes clear is that these delays are often caused by poor ergonomics. So if a worker is constantly bending or reaching awkwardly, they get tired, and tired worker is a slow worker. So to bridge this gap, we utilize three core IE tools. The first one is the time study, which is to identify exactly where the seconds are being lost. So the second one is the verbal assessment, which is to score and fix the risky body movements. And the third one is the 5S methodology, which used to organize the stall so that every tool is in a fixed, easy to reach spot. So previous studies on street vendors prove that even low-cost changes like adjusting table height or organizing a condiment area can significantly boost productivity. So our goal is to fill the research gap by showing that when you design for the workers' comfort, you automatically design for a faster service.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adib Rahim. My matrix number is DD220057. So now I will presenting our methodology for this case study. So for the research design and target study, first is the single case study approach, which is we utilize a qualitative and quantitative case study focusing on Pak Usu Jagung minus BP. Number two, the rationale chosen to allow for an in-depth real-world analysis of how spatial layout, human factors and process sequences interact in a small roadside stall. And then next, product focus, which is the corn in cup was selected as the study baseline due to its high demand and highly repetitive preparation steps. And the integrated goal is to combine time measurement with agronomy assessment to ensure speed improvement, do not sacrifice worker health. Next, the data collection and measurement tools. So for the direct time study, a continuous timing method used to decompose the service cycle into 4 job elements, which is order, retrieval, cooking and packing. Number 2 is postural analysis, the application of the rapid entire body assessment to score risk for musculoskeletal disorders, MSDs, based on trunk, neck and arm position. Number 3 is photographic observation, used to measure workstation height relative to operator elbow height and specific movement path. And next is workplace audit, which is 5S, a baseline audit using sort, set in order, shine, standardize and sustain to identify wasted motion from poor tool organization. Next, the process flow chart. So our study starting with process mapping and problem identification. And then if the issue is confirmed, we can proceed to the measurement. But if no, we need to re-observe the stall workflow. And next, proceed to the time study and REBA analysis. If the data sufficient, we can proceed to the next step, which is redesign. But if the process cannot be accepted, we can collect more timing samples. And then next, the implementation of industrial engineering and ergonomic solution. If the goal met, we can proceed to the final analysis. But if the goal not met, we can adjust the workstation height or tools. And then the last part is the performance and capacity verification. And then we can finish the study. That's all from me. Thank you.
I'll present the results based on the background of our case study. From our observation, corn in cup is identified as the most frequent ordered product, especially during peak hours. This indicates a high demand and continuous workflow during busy periods. We also found that a single operator is responsible for handling all tasks, including food preparation as well as customer service. This increased the workload and the time pressure on the operator. Due to limited workspace, the operator frequently performs reaching and turning movements while working. These repetitive motions are mainly caused by the arrangement of tools and material within a confined area. Additionally, the operator is required to stand for a prolonged period, often involving forward bending and repeated arm extension. Over time, these postures may contribute to physical discomfort and also fatigues. In this slide, I will explain the analysis of the current situation based on the work study conducted. First, the work study focuses on the entire flow of preparing and serving the product, which is divided into 4 main job elements labeled from A to D. Job element A is order taking and payment, where the processing time for this activity is 30 seconds. Job element B is retrieving semi-cooked corn, where the process time is 45 seconds. Job element C involves cooking with toppings, which is the most time consuming, taking about 90 seconds. Finally is job element D, which is packaging and handover, which once again takes 45 seconds. The total observed process time for all 4 elements is 210 seconds. In the second table, a time study calculation is performed. All job elements are manual, thus and are given a performance rating of 1.1. After applying the rating, the normal time increases to 231 seconds. An allowance of 13% is also added, which totals a standard time for completing one full order to be 265.5 seconds. This slide highlights the ergonomic issues identified during the work study. Firstly, the operator experienced prolonged standing throughout the work process, which can lead to leg fatigue. Secondly, there is an awkward trunk bending and reaching during tasks such as retrieving ingredients and handling equipment. Another issue observed is that heavy equipment is placed at excessive height. Additionally, some light work is performed below elbow level, which causes the operator to bend forward unnecessarily. The operator is also exposed to heat during the cooking process, which may lead to fatigue. Lastly, there is a lack of proper tool and ingredient organization, resulting in unnecessary movements. Next is suggested improvement based on the time study analysis. In this improved process, some job elements remain manual, while one key operation has been automated to improve efficiency, which is job element C that represent final cooking with toppings. This step has been changed from a manual process to an automatic process, reducing the processing time from 90 seconds to 60 seconds. As a result, the standard time for this element is significantly reduced. Overall, the process time is reduced to 210 seconds from 210 seconds to 180 seconds, and the total standard time decreases approximately 265.5 seconds to 211.7 seconds. Moving on, this slide shows the proposed ergonomic improvement to the workstation, which is presented in both the front and top layout. Starting with the top view, the layout is redesigned to reduce unnecessary movement. The distance between the operator and the cooking area is minimized, allowing the operator to work more efficiently. The steamer and grill are positioned within easy reach, to reduce excessive bending and reaching. An automatic stirring cooker is introduced to reduce manual effort and repetitive motions. Moving on to the front view, several ergonomic principles are applied. The table height is adjusted to the elbow level, allowing the operator to maintain a neutral posture while working. Adequate fit clearance is provided to reduce strain on the legs during prolonged standing. Storage compartment for tools and equipments are added within arms reachable to improve organization. The steamer is positioned at a safe and accessible height to minimize lifting strain. Finally, this slide summarizes the overall discussion of the study from analysis to final outcome. First, the analysis method used in this study involved a time study and ergonomic assessment. These methods were used to evaluate both work efficiency and operator safety. From the analysis, the main issue identified was the manual stirring, caused service bottleneck and increased operator fatigue, especially during peak operating hours. To address this issue, an improvement was proposed by introducing automatic stirring. This change significantly reduced both the processing time and physical workload on the operator. However, despite the improvement, some ergonomic risks still remain, as prolonged standing, awkward posture and excessive reaching, which need to be managed through proper workstation design. As a result of the proposed improvement, the outcome of this study is improved level of efficiency, greater operator comfort, and better long sustainability of the operation.
Hi, my name is Irfan Husaini by Azmi. My matrix number is CD230235. Now I will continue our presentation about the conclusion and also the future recommendation. Okay, this project shows that service efficiency and ergonomic design are linked and should be improved together, especially a food service small business like Pak Usu Jago Manis BP. By applying industrial engineering principle, the study found that service delay are mainly caused by bottlenecks and also the unnecessary worker movements. By measuring key performance indicators such as service time and throughput helps identify the operational constraint in a structured way. For future recommendation, the first one is a long-term performance evaluation. It can be done by measure service time and also the worker fatigue over several months after the implementations. This will help determine whether the improvements are sustainable or not. The second one is include a comparative study across the multiple food stalls or vendors. By applying the same industrial engineering method to the different types of the small food business, such as burger stall or drink vendors, the researchers can compare the result and identify the common of the bottlenecks and also the economic risks. The third one is explore the use of the digital or semi-automated tools in food stalls. It can be done by using simple digital timers or basic point of sale (POS) system. It can reduce the service time and the error. The fourth one is deeper study about the ergonomic and health impact. This will strengthen the link between the ergonomic design and the worker productivity. The last one is examine layout optimization and simulation modeling. This approach will reduce the trial and errors and help identify the most efficient and ergonomic layout for small food stalls. So that's all from us. Thank you very much.